Okay, so today we start trigonometry. This is section 5.1, and we talk about angles and their measures. Alright, so let's start what we know. Just reviewing a little bit from geometry. Okay. If I had something like this, point A, and I had point B, and I draw the arrow through it, this would be the ray. You can see it's sometimes written like this, AB. Now, on the other hand, if I add, here's our same ray, AB. If I add another ray like this, that goes through a point C, I have the ray AC connected with the ray AB, and now we talk about angle, and we could talk about that as CA, and then B. Sometimes I write my angle symbols like this, just FYI. Okay, these are now angles. So for any angle, let's just draw another generic angle. There are some important terminologies. The angle would be measured in between here. Okay. Let's call that some theta. This is the angle measurement. Okay. This point is known as the vertex. Okay. This side is the initial side. And then the angle gets measured up this way until the terminal side. Some notations for angles. We can notate it like this, and this is known as alpha. We can notate it like this, and this is beta. These are Greek letters. The one I've used here is theta. We also have one like this, which is gamma. And you'll see this one also, which is omega. Now, in a circle, if we have the center of the circle, we could put any angle inside of it. So let's say here's our angle theta. Okay. This is what's going to be known as a central angle, because it starts at the center of the circle. Okay. But what will happen then is if you drew the rays out, there would be a certain portion of the circle that has been cut off, and this is called the intersected arc. Now we can also put angles in the Cartesian plane. Okay, so in our XY plane. When we do that, the x-axis here is going to be the initial side. And we could then sweep out an angle. We have two directions we could go. If I went this direction, and I'm notating that by this arrow, and here was the terminal side, let's say this is an angle alpha. This is known as a positive rotation. On the other hand, what I could do is I could measure an angle downward, like so. This is a different angle, we'll call that beta. this is a negative rotation. So either way, because the initial side was here, these are in standard position. And so what we're going to have to start thinking about is that angles are rotations. So let's think about our standard xy plane, the Cartesian plane. Now we know this. We know that starting from our initial side, one full revolution is 360 degrees. Right? Remember your degree symbols. We're going to want to forget about them, but we have to be careful. Well, if this whole thing is 360 degrees, then if I've gone halfway around, this must be 180 degrees because it's half of 360. And if I only want to go a quarter way around, well, that's half of the half, so this must be 90 degrees. And if I want to go 3/4 the way around, well, that's 90 plus another 90 is 180, plus another 90 is 270 degrees. The angles from 0 to 90 are in quadrant 1. Okay? There's 4 different quadrants here. And so we'll work counterclockwise. This is quadrant 1. This is in quadrant 2. This is in quadrant 3. And this is in quadrant 4. Okay? So quadrant 4 is the angles between 270 and 360. Now there are other angles that are very easy for me to find. The 45-degree line, okay, this is the line y equals x from here to here. Okay, this is 45 degrees. I could extend that through here. So what must this angle be? Well, this angle has to be, if from here to here is 45, this angle also has to be 45. So this angle must be 225 degrees. And we could put the rest in as well. We could put in this 45-degree line y is equal to negative x. Now if this is 45, this is 45. Here's another 45. So this angle must be 135 degrees. And similarly from here to here, 270 plus 45 degrees is 315 degrees. And just to review some terminology, we will say that an angle theta is acute if that angle is less than 90 degrees, but bigger than 0 degrees. And 0 degrees is the same as 360. Okay? Again, we're going to think about angles as rotations. Okay? So the angle of 0 degrees is I go nowhere. The angle of 360 degrees is I go all the way around once. So acute. And we can also say that an angle is obtuse if that angle now falls in between 90 and 180. Okay, so these are some terminologies and some basic setups for us. So let's look at some other angles. Okay. Let's say we have this angle. Let's say we have theta that's equal to 150 degrees. Well, where would I sketch that? Well, I know if this is 0 and this is 90 and this is 180, the 45 degree line is 135, so it is 30 degrees above 180. It would be here, 150. This would be theta, which is equal to 150 degrees. Now, alternatively, I could look at something called beta, and I would want to look at beta being at negative 210 degrees. So things get a little more different here, because this is a negative rotation of an angle. So I would start at the initial side, and if I do that, now this is negative 90 degrees, this is negative 180 degrees, and I need to go another 30 degrees negative. So it would turn out my angle beta would fall here. And perhaps I should draw this in black to make this a little more clear. Okay. Now, what we're saying here is clearly from here, these two angles are not equal. One's a positive rotation, one's a negative rotation. From here, however, we see that they have a relationship, and that is that they have the same terminal side. And there's a word for that, and that means theta and beta are, the word is coterminal. That is, that they end in the same space. Now let's consider this. Okay. Let's say I have some angle alpha that is 150 degrees, and then I add another 360 degrees to that. It is the angle 510 degrees. If I was to draw this, then it is a positive rotation of an angle. So I would need to go around. There's 180, that's 360 degrees. Okay. Plus I need to go another 150. So this is the angle alpha. Again, alpha, beta, and theta are not equal. Okay. Alpha is another coterminal angle. And it is coterminal with theta and beta. Okay. And it turns out there's an infinite amount of these. Okay. If I took 210 and kept looping it around once, that would be another angle. If I looped it around again, it would be another, and another. Okay, so there is an infinite amount of coterminal angles, and these angles are not equal, and we really have to keep in mind that angles are rotations. This is going to be our big mantra. Now notice when I was doing this, I was measuring angles and I was making sure to put a degree symbol on there. That is an important distinction. Oh, I missed one right there. It's an important distinction to make because we have another way to measure angles, and that is known as radian measure. And that will make our calculations much easier. So here, let's talk about radians. So let's put a circle down so we can understand. Okay. And let's make this what we'll call a unit circle. So this is the point 0, 1. So what makes this a unit circle then is it is a circle with a radius 1. Now let's put in some angle. Okay. It is a central angle. Let's call it alpha. And this angle then has cut off a portion of this circle from here to here. This is the intercepted arc. Okay. So we usually denote that with S. Okay. Another term is arc length. Because the length of this arc will change as the value of the angle changes. So what is, let's see, this is a unit circle. And what is the definition then for radian measure? Well, the length of the intercepted arc, remember we'll denote that as S, this length in here, is equivalent to the measurement of the angle, in this case we're calling the angle alpha, in radians. And that's going to be a really big help for us, okay? That is, this angle alpha will be the same as this arc length if we're measuring in radians. If we're not measuring in radians, if we're in degrees, we're going to have to do some conversions. It will not be true. Okay. Now, let's think about what the circumference of a circle is. The circumference of a circle is 2 pi times the radius. Okay, that's for any circle. Now, in a unit circle, that is where the radius is 1, we get the circumference is 2 pi times 1, which is simply 2 pi. And that's going to help us describe our measurement in radians. Okay. So, if we were to put the circle on here, we would see 1 full revolution is 2 pi. So what would it be if I only went halfway around? Well, if all the way around is 2 pi's, then half of 2 pi is 1 pi. What about our 90 degrees? What does that correspond to? Well, it has to be half of pi. And so you just take pi and divide it in half. What about 3/4? Well, okay. If this is 1 pi over 2, this is 2 pi's over 2, which is just pi. This has to be 3 pi's over 2. And then if we add 1 more pi, we get to 4 pi's over 2, which is 2 pi. 1 full revolution is 2 pi. Okay? So we half it, half again, and count up. Okay, well, what about these 45-degree lines. What do they correspond to in radians? Well, this has to be 1/2 of this angle, which is pi over 2. So this has to be pi's over 4. And we can count up. So if this is 1 pi over 4, this is 2 pi's over 4. 2 pi's over 4 is pi over 2. Okay, so 1 pi over 2, 1 pi over 4, 2 pi's over 4. This has to be 3 pi's over 4. 4 pi's over 4, which is just pi. This is 5 pi's over 4. This is 6 pi's over 4, which reduces to 3 pi over 2. And this 7 pi's over 4. And then finally, we would add another pi over 4 to get to 8 pi over 4, which is 2 pi. So 1 revolution is 2 pi radians. Sometimes they'll write that as 2 pi rad or rads. And most commonly, we will just write 2 pi. Well, what do we know for sure then? We know then that pi radians, well, that's equivalent to 180 degrees. So if I go pi radians, I've gone 180 degrees. And we're going to use that to help us convert in between radians and degrees. So if we have that pi radians is equal to 180 degrees, well, what is 1 radian? Well, how would I get that? Well, I can just divide by pi, but if I'm dividing this side by pi, I also have to divide that side by pi. Then the pi's would cancel, and I'd be left with the 1 radian. So 1 radian would be equal to 180 over pi. Okay, so this is one formula we'll need. It'll help us in converting. Let's look at it again if we wanted to go the other way. If we have pi radians is equal to 180 degrees, and I want to know about 1 degree, well, then I want to divide by 180. So 1 degree is equal to pi over 180 radians. Okay, so let's do an example of that. Let's convert 240 degrees to radians. Okay, so notice these are our values of 1, right? Okay, so what I want to do is I want 240 degrees, and I'm going to multiply by the number 1, okay, in such a way that the degrees will cancel. Okay. I guess I should put my degree symbols in here. Alright, so this is the degree that I want to use this one because I want the degrees to cancel. Okay. So this is just the number 1. Okay. Now the degrees will cancel. And I'm left with, now you could think about this as 240 over 1. So this is 240 pi over 180. But we can simplify this. Okay. They both end in 0, so we could divide by 10. Now 6 goes into 18, 6 goes in 3 times, and 6 goes into 24 4 times. So when we're done, I have the 4 times the pi over just 3. So 240 degrees is 4 pi over 3. Let's go the other way. Let's try, well, I don't know. Five pi over 4, 2 degrees. Okay, well, I have 5 pi over 4, and I want to multiply this by 1, and I want to get out of the pi's and be left with degrees. So I'll need the pi's to cancel, and I'll multiply by 180. Okay, so this is just the number 1. Okay. And by allowing for that, then the pi's will cancel. So we'll be left with 5 times 180 degrees over 4. But we can simplify that. 2 will go in here twice, and then here 90 times. And 2 goes into 90 45 times. Okay. So what we're left with is 45 times 5. So 5 times 5 is 25. 5 and 4 is 20. It's 225 degrees. So this is how you can convert between the two. Converting from radians to degrees, finding coterminal angles. Then I guess that brings us to arc length. We could do some coterminal. Okay. Okay, again, here we have a circle. Okay. Now, let's say it's not on a unit circle. Okay. So, this is some measurement r for the radius. And again, we have some angle here, alpha. And we're looking for this, the arc length. So what we have then, because we're not on the unit circle, is we know this, that the circumference is equal to 2 pi r. So what is the value of this arc length? Well, we need to find the portion of the circle that alpha actually is. And then we could multiply that by the circumference, and we would find the arc length. So S would be equal to, well, what portion of the circle does alpha take up? Well, it's alpha out of all the way around, which is 2 pi. This is the portion. And then we can multiply that by the circumference. when we do that, remember this is like 2 pi over 1, okay, then what we're left with then is simply s is equal to alpha times the radius. So you'll hear me say it oftentimes. I just used the letter alpha here. I could have used theta. So s is equal to r theta. Okay. This is the fraction of the circle. But the important thing here is this will only work if theta is in radians. If this is in degrees, it is not true. Okay. So if you get a problem where alpha is given in degrees, your angle is given in degrees, you must convert to radians first. And another formula that you'll need for your homework is the area of that sector. Okay. So this area, okay, not the arc length anymore, but the area of that, the area is going to be equal to 1/2 theta, or alpha, whatever you want to use, r squared. And again, theta must be in radians. Okay, I want to do just a couple more examples about coterminality with you, and then we will, I will let you get started with your homework. We'll be finished with the lecture. So for example, let's say we have an angle theta which is equal to negative 45 degrees. I want to find a positive coterminal angle in one rotation. That is, I want to find another angle, we'll call it alpha, that goes between 0 and 360 degrees. So this is theta, which is negative 45 degrees. But what I would like to find then is the angle in positive rotation that is coterminal with that. So the way that we can find that is that we take our negative 45 that we start with, and we're going to add to it an entire looping, which is 360 degrees. So that's the same as 360 degrees minus 45, and 360 minus 45, carry the 1, that's 5, 5 minus 4. So this angle will be 315 degrees. Let's say we have theta is equal to 19 pi over 4. And we want to find a positive coterminal. Let's call it beta in this one. And we would like beta to go now in radian measure in one looping, so it needs to go between 0 and 2 pi. I guess the question we could ask ourselves is, how do we know that this angle is not inside of here? Well, let's think about what 2 pi is. 2 pi over 1. Let's think about that in terms of force. So what we'd have to do is get a common denominator. So we see then that 8 pi over 4 is equal to 2 pi. So this is much larger than that. And that's how we know that it's not between 0 and 2 pi. So let's just keep subtracting off rotations until we get to a value that's in between 0 and 8 pi's over 4, simply because we're given the over 4. So here we go. 19 pi over 4, I want to subtract off one rotation, which is 8 pi over 4. That's equal to 11 pi's over 4. Now 11 pi's over 4 is still larger than 8 pi's over 4, so we're not in this range. So we need to subtract off another rotation. And now 11 pi's over 4 minus 8 pi's over 4, well, that's 3 pi's over 4. And 3 pi's over 4 is greater than 0 and less than 8 pi over 4. So our fractions are going to become very important to us. So let's say we were to graph this. 3 pi over 4 is here. 1 pi over 4, 2 pi's over 4. This was 3 pi's over 4. Okay, so this is the angle that we found. The original angle we were given has 2 more rotations than that. So if we had to graph that, it'd be 1 full rotation, 2 full rotations, and then the 3 pi over 4. This is how you graph the angle 19 pi over 4. Okay, I think so. Adding and subtracting fractions is going to come in to play with this. I hope this gives you a firm grasp on what we're doing, so we can start your homework. Go ahead and get started, and remember, if you have any questions, please email me.